Hey everyone, welcome to the Latent Space podcast. This is Alessio, partner and CTO in residence at Decibel Partners, and I'm joined by my co-host Swix, founder of Small AI.
Hey, and today we have in the studio Soumith, Chintala. Welcome.
Thanks for having me.
On one of your rare visits from New York, where you live.
Yeah.
You got your start in computer vision at NYU with Jan Kun. That was a very fortuitous start. I was actually listening to your interview on the Gradient podcast. So if people want to know more about like the history of Soumith, the history of PyTorch, they can go to that podcast. We won't spend that much time there. But I just was marveling at your luck, or I don't know if it's your luck or your drive to find AI early and then find like the right quality mentor, because I guess Jan really sort of introduced you to that world.
You're talking about extrinsic success, right? Like a lot of people just have drive to do things that they think is fun. And a lot of those things might or might not be extrinsically perceived as like good and successful. I think I just happen to like something that is now like one of the coolest things in the world or whatever. But if I happen, the first thing I tried to become was a 3D VFX artist. And I was really interested in doing that, but I turned out to be very bad at it. So I ended up not doing that further. But even if I was good at that, whatever, and I ended up going down that path, I probably would have been equally happy. It's just like maybe like the perception of, oh, is this person successful or not might be different. But I think like after a baseline, like your happiness is probably more correlated with your intrinsic stuff.
Yes. I think Dan Pink has this book on Drive that I often refer to about the power of intrinsic motivation versus extrinsic and how long extrinsic lasts. It's not very long at all.
Yeah.
But anyway, now you are an investor in Runway. So in a way, you're working on VFX.
Yes. I mean, in a very convoluted way.
It reminds me of the Ed Catmull. I don't know if you guys know, but he actually tried to become an animator in his early years and failed or didn't get accepted by Disney, and then went and created Pixar and then got bought by Disney and created Toy Story.
Yeah.
So you joined Facebook in 2014 and eventually became creator and maintainer of PyTorch. Yep. And there's a long story there you can refer to on the Gradient. But you also I think maybe people don't know that you also involved in more sort of hardware and cluster decision affair. And we can dive into more details there because we're all about hardware this month. And then finally, I don't know what else. Like, what else should people know about you on the personal side or professional side?
I think open source is definitely like a big passion of mine and probably forms a little bit of my identity at this point. I am irrationally interested in open source, right? It's like one of those things that I attribute to, I think open source has that fundamental way to distribute opportunity in a way that is very powerful. Like I grew up in India. I didn't have internet for a while. In college, actually, I didn't have internet except for like GPRS or whatever. So just having knowledge was very centralized, but like I saw that evolution of knowledge slowly getting decentralized, and that ended up helping me learn quicker and faster for like $0. And I think that was a strong reason why I ended up where I am. So like that, like the open source side of things, I always push regardless of like what I get paid for. Like I think I would do that as a passion project on the side.
Yeah, that's wonderful. And we'll talk about the challenges as well that open source has, open models versus closed models. But maybe you want to touch a little bit on PyTorch before we move on to sort of meta AI in general.
Mm-hmm. Yeah, we kind of touched on PyTorch in a lot of episodes. So we had George Hotz from TinyGrad. He called PyTorch a CISC and TinyGrad a RISC. I would love to get your thoughts on PyTorch design direction as far as, I know you talk a lot about kind of having a happy path to start with and then making complexity hidden away, but then available to the end user. One of the things that George mentioned is I think you have like 250 primitive operators in PyTorch. I think TinyGrad is 4. So How do you think about some of the learnings that maybe he's going to run into that you already had in the past 7-8 years almost of running PyTorch?
Yeah, I think everyone starts. There's different models here, but like I think it's two different models that people generally start with. Either they go like, I have a grand vision, and I'm gonna build like a giant system that achieves this grand vision, and my V1 is or like super like complex, feature complete, whatever. Or other people say they will get incrementally ambitious, right? And they say, oh, we'll start with something simple, and then we'll slowly layer out complexity in a way that optimally applies Huffman coding or whatever, like, where the density of users are and what they're using, I would want to keep it in the like easy, happy path. And where the more niche advanced use cases, I'll still want people to try them, but they need to take additional frictional steps. George, I think, just like we started with PyTorch, George started with the incrementally ambitious thing. I remember TinyGrad used to be like, we would be limited to 1,000 lines of code, and I think now it's like 5,000. So I think there's no real like magic to which why PyTorch has the kind of complexity. I think it's like probably partly necessitated and partly because we built with the technology available under us at that time. If you had to rewrite PyTorch is like 190,000 lines of code or something at this point. I think if you had to rewrite it, we would probably think about ways to rewrite it in like a vastly simplified way for sure. But a lot of that complexity comes from the fact that in a very simple, explainable way, you have memory hierarchies. You have CPU has like 3 levels of caches, and then you have DRAM and SSD, and then you have network. Similarly, GPU has several levels of memory, and then you have like different levels of network hierarchies, NVLink plus like InfiniBand or Rocky or something like that, right? And the way the flops are available on your hardware, they are available in a certain way, and your computation is in a certain way, and you have to retrofit your computation onto both the memory hierarchy and like the flops available. When you're doing this, it is actually like a fairly hard mathematical problem to do this setup, like you find the optimal thing. And finding the optimal thing is like, what is optimal? What is optimal depends on like the input variables themselves. So like, okay, like what is the shape of your input tensors, and like what is the operation you're trying to do, and like various things like that. Finding that optimal configuration, and writing it down in code, is not the same for every input configuration you have. Like for example, just as the shape of the tensors change, let's say you have 3 input tensors into like a sparse dot product or something like that. The shape of each of these input tensors will vastly change how you do this optimally placing this operation onto the hardware in a way that will get you maximal throughput. So a lot of our complexity comes from writing out like hundreds of configurations for each single PyTorch operator and templatizing these things, and like symbolically like generating the final CUDA code or like CPU code. There's no way to avoid it, because mathematically we haven't found symbolic ways to do this that also keep compile time near 0. You can write a very simple framework, but then you also should be willing to eat the long compile times of like searching for that optimal performance at runtime. So that's the trade-off. There's no like, I don't think like, unless we have like great breakthroughs like George's vision is achievable, like, or like he should be thinking about a narrower problem, such as I'm only going to make this for like work for self-driving car connets, or like I'm only going to make this work for like LLM transformers of the Llama style. Like if you start narrowing the problem down, you can make a vastly simpler framework. But if you don't, if you need the generality to power all of the AI research that is happening and keep like zero compile time and all these other factors, I think it's not easy to avoid the complexity.
That's interesting. And we kind of touched on this with Chris Ladner when he was on the podcast. If you think about frameworks, they have the model target, they have the hardware target, they have different things to think about. He mentioned when he was at Google, TensorFlow, it's trying to be optimized to make TPUs go burr, know, and go as fast. I think George is trying to make, especially AMD stack, be better than ROCm. How come PyTorch has been such a Switzerland versus just making Meta hardware go burr?
First, Meta is not in the business of selling hardware. Meta is not in the business of cloud compute. We kind of, the way Meta thinks about funding PyTorch is, it's just like we're funding it because it's net good for Meta to fund PyTorch, because PyTorch has become a standard and a big open source project. And generally, it gives us a timeline edge. It gives us like various like leverage, like and all that, like within our own work. So why is PyTorch like more of a Switzerland rather than being opinionated? Like, I think the way we think about it is not in terms of Switzerland or not. We actually, the way like we articulate it to all hardware vendors and software vendors and all who come to us being like, we want to build a backend in core for PyTorch and ship it by default, is like, we just only look at our user side of things. Like if users are using a particular piece of hardware, then we want to support it. We very much don't want to king make the hardware side of things. So as like the MacBooks have GPUs, and as that stuff started getting increasingly interesting, we pushed Apple to push some engineers and work on the MPS support, and we spent significant time from like Meta-funded engineers on that as well, because a lot of people are using the Apple GPUs and there's demand. So like we kind of mostly look at it from the demand side. We never look at it from like, oh, which hardware should we start taking opinions on?
Is there a future in which, because Mojo or Modular's Mojo is kind of a superset of Python, is there a future in which PyTorch might use Mojo features optionally?
I think it depends on how well integrated it is into the Python ecosystem. So if Mojo is like a pip install and it's readily available and users feel like they can use Mojo so smoothly within their workflows, within in a way that just is low friction, we would definitely look into that. Like in the same way, like PyTorch now depends on Triton, like OpenAI Triton. And we never had a conversation that was like, that's like a dependency. Should we just build a Triton of our own? Or should we like use Triton? Like it almost doesn't, like those conversations don't really come up for us. The conversations are more like, well, does Triton have like 10,000 dependencies and is it hard to install? Like we almost don't look at these things from like a strategic leverage point of view. We look at these things from like a user experience point of view. Like, is it easy to install? Is it like smoothly integrated? If so, we should consider, and does it give enough benefits for us to like start depending on it? If so, yeah, we should consider. That's how we think about it.
You're inclusive by default, as long as it meets like the minimum bar. But like maybe I phrased it wrongly. Maybe it's more like, okay, like what problems would you look to solve?
Okay.
Right. That you have right now.
I think it depends on what problems Mojo will be useful at.
It's more performance, mainly a performance pitch, some amount of cross-compiling pitch.
Yeah, I think like the performance pitch for Mojo was like, we're going to be performant even if you have like a lot of custom stuff. Like you can write arbitrary custom things and like we will be performant. And that value proposition is not clear to us from the PyTorch side to consider it for PyTorch. So PyTorch exposes like, it's actually not 250 operators, like 1,000 operators. PyTorch exposes about 1,000 operators, and people kind of write their ideas in the 1,000 operators of PyTorch. Mojo's like, well, maybe like it's okay to completely sidestep those like 1,000 operators of PyTorch and just write it in a more natural form. Just write like raw Python, like write for loops or whatever, right? So from the consideration of how do we intersect PyTorch with Mojo, like I can see one use case where you're like, you have custom stuff for some parts of your program, but like mostly it's PyTorch. And so we can probably figure out how to like make it easier for, say, torch.compile to like smoothly also consume Mojo subgraphs and like, you know, the interoperability being actually usable. That I think is valuable, but like Mojo as a fundamental front end would be replacing PyTorch, not like augmenting PyTorch. So in that sense, I don't see a synergy in more deeply like integrating Mojo.
So call out to Mojo whenever they have written something in Mojo and there's some performance related thing going on. And then since you mentioned Apple, what should people think of PyTorch versus MLX?
I mean, MLX is early, and I know the folks well. Ani used to work at Fair, and I used to chat with him all the time. He used to be based out of New York as well. The way I think about MLX is that MLX is specialized for Apple right now. It has a happy path because it's like it's defined its product in a narrow way. At some point, MLX either says we will only be supporting Apple and we will just focus on enabling, you know, this is a framework if you use your MacBook, but once you like go server side or whatever, that's not my problem and I don't care. Or MLS, it enters like the server side set of things as well. Like one of these two things will happen, right? If the first thing will happen, like MLX's overall addressable market will be small, but it probably do well within that addressable market. If it enters the second phase, they're going to run into all the same complexities that we have to deal with. They will not have any magic wand, and they will have vastly more complex work to do. They probably wouldn't be able to move as fast, and
like having to deal with distributed compute.
Distributed NVIDIA and AMD GPUs, like just like having a generalization of the concept of a backend, how they treat compilation with plus overheads. Right now, they deeply assume like the whole MPS graph thing. So they need to think about all these additional things if they end up expanding onto the server side, and they'll probably build something like PyTorch as well, right? Like, you know, eventually that's where it will land. And I think there they will kind of fail on the like lack of differentiation. Yeah. Like it wouldn't be obvious to people why they would want to use it.
I mean, there are some cloud companies offering M1 and M2 chips on servers. I feel like it might be interesting for Apple to pursue that market, but it's not their core.
Yeah, strength. I mean, if Apple can figure out their interconnect story, maybe, like then it can become a thing. Yeah.
Honestly, that's more interesting than the cars.
Yes. I think like, I mean, the moat that NVIDIA has right now, I feel like, is that they have the interconnect that no one else has. Like AMD GPUs are pretty good. I'm sure there's various silicon that is not bad at all, but like the interconnect, like NVLink is uniquely awesome. So I'm sure the other hardware providers are working on it, but
I feel like when you say it's uniquely awesome, you have some appreciation of it that the rest of us don't. The rest of us just like, you know, we hear marketing lines, but what do you mean when you say NVIDIA is very good at networking? Obviously, they made the acquisition maybe like 15
just
years
like
ago.
The bandwidth it offers and the latency it offers. I mean, like TPUs also have a good interconnect, but you can't buy them. So you have to go to Google to use it.
Got it.
Who are some of the other Fair PyTorch alumni that are building cool companies? I know you have Fireworks AI, Lightning AI. Lepton. And Yanqing, you knew since college when he was building coffee?
So Yanqing and I used to be framework rivals, like Cafe, Torch. I mean, we were all a very small, close-knit community back then. Cafe, Torch, Tiano, Chainer, Keras, various frameworks. I mean, it used to be like more like 20 frameworks. I can't remember all the names. CCV by Liu, who is also based out of SF. And I would actually one of the ways it was interesting is like you went into the framework guts and saw if someone wrote their own convolution kernel or they were just copying someone else's. And there were 4 or 5 convolution kernels that were unique and interesting. There's one from this guy out of Russia. I forgot the name, but I remembered who was awesome enough to have written their own kernel. And at some point there, I built out these benchmarks called ConNet benchmarks.
Yep.
That they're just benchmarking all the convolution kernels that are available at that time. And it hilariously became big enough that at that time AI was getting important, but not important enough that industrial strength players came in to do these kind of benchmarking and standardization like we have MLPerf today. So a lot of the startups were using ConNet benchmarks in their pitch decks as on ConNet benchmarks, this is how we fare, so you should fund us. I remember Nirvana actually was at the top of the pack because Scott Gray wrote amazingly fast convolution kernels at that time. Very interesting, but separate times. But to answer your question, Alessio, I think mainly Lepton, Fireworks are the 2 most obvious ones. But I'm sure the fingerprints are a lot wider. They're just people who worked within the PyTorch Cafe 2 cohort of things and now end up at various other places.
Yeah. I think as both as an investor and a people looking to build on top of their services, it's uncomfortable / I don't know what I don't know pitch because I've met Yanqing and I've met
Lin Chao.
I've met these folks and they're we were deep in the PyTorch ecosystem and we serve billions of inferences a day or whatever at Facebook, and now we can do it for you. And I'm like, okay, that's great. What should I be wary of or cautious of when these things happen? Because I'm obviously this experience is extremely powerful and valuable. I just don't know what I don't know. What should people know about these sort of new inference as a service companies?
At that point, you would be investing in them for their expertise and of one kind. So if they've been at a large company, but they've been doing amazing work, you would be thinking about it as what these people bring to the table is that they're really good at GPU programming or understanding the complexity of serving models once it hits a certain scale, various expertise from the infra and AI and GPU's point of view. What you would obviously want to figure out is whether their understanding of the external markets is clear, whether they know and understand how to think about running a business, understanding how to be disciplined about making money or various things that.
Maybe I'll put it I will de-emphasize the investing bit and just more as a potential customer.
Oh, okay.
It's more okay, your PyTorch gods, of course. What else should I know?
I mean, I would not care about who's building something if I'm trying to be a customer. I would care about whether
benchmarks.
Yeah, I use it, and it's usability and speed, reliability and speed, right?
Quality as well.
Yeah, if someone from some random unknown place came to me and said, use our stuff, it's great, like and I have the bandwidth, I probably will give it a shot. And if it turns out to be great, like I'll just use it.
Okay, great. And then maybe one more thing about benchmarks, since we already brought it up, and you brought up Confident benchmarks. There was some recent drama around AnyScale. The AnyScale released their own benchmarks, and obviously they look great on their own benchmarks, but maybe didn't give the other. I feel like there are two lines of criticism. One, which is they didn't test sort of apples for apples on the kind of endpoints that the other providers that they are competitors with, on their benchmarks, and that is due diligence baseline. And then the second would be more just like optimizing for the right thing. You had some commentary on it. I'll just kind of let you riff.
Yeah, I mean, in summary, basically my criticism of that was AnyScale built these benchmarks for end users to just understand what they should pick, right? And that's a very good thing to do. I think what they didn't do a good job of is give that end user a full understanding of what they should pick. Like they just gave them like a very narrow slice of understanding. I think they just gave them latency numbers, and that's not sufficient, right? Like you need to understand your total cost of ownership at some reasonable scale, not like, oh, like one API call is like 1 cent, but like 1,000 API calls are like 10 cents, or like, like people can misprice to cheat on those benchmarks. So you want to understand, okay, like how much is it going to cost me if I actually subscribe to you and do like 1 million API calls a month or something? And then you want to understand the latency and reliability, not just from like one call you made, but like an aggregate of calls you made over several various times of the day and times of the week.
Yeah.
And the nature of the workloads, like it's like, is it just like some generic single paragraph that you're sending that is cacheable, or like is it like testing of real world workload? I think that kind of rigor, like in presenting that benchmark, wasn't there. It was a much more narrow sliver of what should have been a good benchmark. That was my main criticism. And I'm pretty sure if before they released it, they showed it to their like other stakeholders who would be caring about this benchmark because they are present in it, they would have easily just pointed out these gaps. And I think they didn't do that, and they just like released it. So I think those were the two main criticisms. I think they were fair, and Robert took it well. And
he took it very well. Yeah. I will have him on at some point, and we'll discuss it. But I think it's important I think the market being maturing enough that people start caring and competing on these kinds of things means that we need to establish what best practice is. Right. Because otherwise everyone's going to play dirty. Yeah, absolutely. My view of the LLM inference market in general is that it's like the laundromat model. Like the margins are going to drive down towards the bare minimum. Like it's going to be all kinds of arbitrage between how much you can get the hardware for and then how much you sell the API and how much like latency your customers are willing to let go. Like you need to figure out how to squeeze your margins. Like what is your unique thing here? Like I think like Together and Fireworks and all these people are trying to build some faster CUDA kernels and faster like hardware kernels in general. But those modes only last for a month or two. Like these ideas quickly propagate. Even if they're not published? Even if they're not published, like the idea space is small. Okay. So even if they're not published, the discovery rate is going to be pretty high. It's not like we're talking about a combinatorial thing that is really large. You're talking about like llama-style LLM models. And we're going to beat those to death, like on like a few different hardware SKUs, right? Like it's not even like we have a huge diversity of hardware you're going to aim to run it on. Now, when you have such a narrow problem and you have a lot of people working on it, like the rate at which these ideas are going to get figured out is going to be pretty rapid. Is it like a standard bag of tricks? Like the standard one that I know of is, fusing operators. And yeah, it's the standard bag of tricks on like figuring out how to like improve your memory bandwidth and all that. Yeah. Okay. Interesting.
Any ideas instead of things that are not being beaten to death that people should be paying more attention to?
One thing I was like, you have 1,000 operators, right? Like, what's the most interesting usage of PyTorch that you're seeing, maybe outside of this little bubble?
So PyTorch, it's very interesting and scary at the same time, but basically it's used in a lot of exotic ways, like from the ML angle, like, okay, like what kind of models are being built? And you get all the way from like state space models and all these things to like stuff that like nth order differentiable models, like neural ODEs and stuff like that. I think like there's one set of interestingness factor from like the ML side of things, and then there's the other set of interesting factor from the applications point of view. It's used in Mars rover simulations, to drug discovery, to Tesla cars, and there's a huge diversity of like applications in which it is used in. So in terms of the most I think like in terms of the most interesting application side of things, I think I'm scared at how many interesting things that are also very critical and really important it is used in. If I think the scariest was when I went to visit CERN at some point, and they said they were using PyTorch, and they were using GANs at the same time for like particle physics research. And I was scared more about the fact that they were using GANs than they were using PyTorch, because at that time I was like a researcher focusing on GANs. The diversity is probably the most interesting. How many different things it is being used in. I think that's the most interesting to me from the applications perspective. From the models perspective, I think I've seen a lot of them. Like the really interesting ones to me are where we're starting to combine search and symbolic stuff with differentiable models. I think like the whole AlphaGo style models is one example, and then I think we're attempting to do it for LLMs as well with like various reward models and then search. I mean, I don't think PyTorch is being used in this, but like the whole alpha geometry thing was interesting, because again, it's an example of combining the symbolic models with the gradient-based ones. But there are stuff like alpha geometry that PyTorch is used at, especially when you intersect biology and chemistry with ML. Like in those areas, you want stronger guarantees on the output. So yeah, maybe from the ML side, those things to me are very interesting right now.
Yeah. People are very excited about the alpha geometry thing, and it's kind of like, for me, it's theoretical. It's it's great. You can solve some Olympiad questions. I'm not sure how to make that bridge over into the real world applications, but I'm sure they will figure it out.
Let me give you an example of it. You know how like the whole thing about synthetic data will be the next rage in LLMs is a thing.
It already is a rage.
Which I think is fairly misplaced in how people perceive it. People think synthetic data is some kind of magic wand that you wave and it's going to be amazing. Synthetic data is useful in neural networks right now because we as humans have figured out a bunch of symbolic models of the world, or made up certain symbolic models because of human innate biases. So we've figured out how to ground particle physics in a 30-parameter model. And it's just very hard and to compute, as in like it takes a lot of flops to compute, but like it only has 30 parameters or so. I mean, I'm not a physics expert, but like it's a very low rank model. We built mathematics as a field that basically is very low rank. Language, like a deep understanding of language, like the whole syntactic parse trees and like just understanding how language can be broken down into a formal symbolism is something that we figured out. So we basically, as humans, have accumulated all this knowledge on these subjects, either synthetic, I mean, we created those subjects, in our heads, or like we've grounded some real world phenomenon into a set of symbols. But we haven't figured out how to teach neural networks symbolic world models directly. The only way we have to teach them is generating a bunch of inputs and outputs and gradient descending over them. Mm-hmm. So in areas where we have the symbolic models, but we like, and we need to teach all like the knowledge we have that is better encoded in the symbolic models, what we're doing is we're generating a bunch of synthetic data, a bunch of input-output pairs, and then giving that to the neural network and asking it to learn the same thing that we already have a better low-rank model of in gradient descent in a much more over-parameterized way. Outside of this, like where we don't have good symbolic models, like synthetic data obviously like doesn't make any sense. So synthetic data is not a magic wand where it'll work in all cases, in every case, whatever. It's just where we as humans already have good symbolic models of, we need to impart that knowledge to neural networks, and we figured out the synthetic data is a vehicle to like impart this knowledge to. So, but people, because maybe they don't know enough about synthetic data as a notion, but like they hear like, the next wave of data revolution is synthetic data. They think it's some kind of magic where we just create a bunch of random data somehow. They don't think about how. And then they think like that's just the revolution. And I think that's maybe like a gap in understanding most people have in this hype cycle.
Yeah, well, it's a relatively new concept. So
yeah.
Oh, there's two more that I'll put in front of you and then see what you respond. One is, I have this joke that it's it's only synthetic data if it's from the Mistral region of France. Otherwise, just a sparkling distillation, which is what news research is doing. Like they're distilling GPT-4 by creating synthetic data from GPT-4, like creating mock textbooks inspired by Phi2, and then fine-tuning open source models like Llama.
Yeah.
And so should we call that synthetic data? Should we call it something else? I don't know, but it's...
Yeah, I mean, the outputs of LLMs, are they synthetic data? They probably are, but I think it depends on the goal you have. If your goal is like you're creating synthetic data with the goal of trying to distill GPT-4's superiority into another model, I guess you can call it synthetic data, but it also feels like disingenuous because your goal is like, I need to like copy the behavior of GPT-4, and
it's also not just behavior but data set. I've often thought of this as data set washing. Like you need one model at the top of the chain. Unnamed French company that has makes a model that has all the data in it that we don't know where it's from, but it's open source. Hey, and then we distill from that. And it's great. But they also, to be fair, they also use larger models as judges for preference ranking, right? Like so.
Yes.
That is, I think, a very, very accepted use of synthetic.
Correct. I think it's a very interesting time where we don't really have good social models of what is acceptable depending on how many bits of information you use from someone else, right? It's like, okay, you use like 1 bit. Is that okay? Mm-hmm. Yeah, that's accepted to be okay. Okay, what about if you use like 20 bits? Is that okay? But I don't know. What if you use like 200 bits? Like, I don't think we as society have ever been in this conundrum where we have to be like, where is the boundary of copyright, or where is the boundary of socially accepted understanding of copying someone else?
Yeah.
Like this, like we haven't been tested this mathematically before, in my opinion.
Yeah, and whether it's transformative use.
Yes.
I think this New York Times OpenAI case is going to go to the Supreme Court.
Yeah.
We'll have to decide it because
I think it'll be very interesting.
Never had to deal with it before. And then finally, for synthetic data, the thing that I'm personally exploring is solving this very stark paradigm difference between RAG and fine-tuning, where you can kind of create synthetic data off of your retrieved documents, and then fine-tune on that. that's kind of synthetic. All you need is variation or diversity of samples for you to fine tune on, and then you can fine tune new knowledge into your data set, your model.
Yeah.
I don't know if you've seen that as a direction for synthetic data.
I think that is like you're basically trying to create what you're doing is you're saying, well, language, I know how to parameterize language to an extent.
Mm-hmm. Yeah.
And I need to teach my model variations of this input data so that it's resilient or invariant to language uses of that data.
Yeah, it doesn't overfit on.
Yeah. So I think that's 100% like synthetic, right? You understand, like the key is like you create variations of your documents, and you know how to do that because you have a symbolic model or like some implicit symbolic model of language.
Okay.
Do you think the issue with symbolic models is just the architecture of the language models that we're building? I think like maybe the thing that people grasp is like the inability of transformers to deal with numbers because of the tokenizer. Is it a fundamental issue there too? And do you see alternative architectures that will be better with symbolic understanding?
I am not sure if it's a fundamental issue or not. I think we just don't understand transformers enough. Mm-hmm. I don't even mean transformers as an architecture. I mean like the use of transformers today, like combining the tokenizer and transformers and the dynamics of training, like when you show math-heavy questions versus not. I don't have a good calibration of whether I know the answer or not. There's common criticisms that are like, well, transformers will just fail at X. But then when you scale them up to sufficient scale, they actually don't fail at that X. I think this is entire subfield where they're trying to figure out these answers called like the science of deep learning or something. So we'll get to know more. I don't know the answer.
Got it. Let's touch a little bit on just meta AI and stuff that's going on there. Maybe I don't know how deeply you're personally involved in it, but you're our first guest from meta AI, which is really fantastic. And Llama 1 was you are such a believer in open source. Llama 1 was more or less like the real breakthrough in open source AI. The most interesting thing for us on covering on this in this podcast was the death of Chintala, as people say. Any interesting insights there around like the scaling models for open source models or smaller models or whatever that design decision was when you guys were doing it?
So Llama 1 was Guillaume Lampol and team. There was OPT before, which I think I'm also very proud of.
That's true.
Because we bridged the gap in understanding of how complex it is to train these models to the world. Like until then, no one really, in gory detail, published
the logs.
Yeah, like why is it complex? And everyone says like, oh, it's complex, but no one really talked about why it's complex. So I think OPT was cool. We probably
also I met Susan and she's very, very outspoken.
Yeah, we probably I think didn't train it for long enough, right? Like that's kind of obvious in retrospect.
For a 175B.
Yeah,
but, we trained it according. You trained it according to Chintala at the time, or
I can't remember the details, but I think it's a commonly held belief at this point that like, well, if we trained OPT longer, it would actually end up being better. Llama 1, I think, was, Guillaume Lampol and team Guillaume is fantastic and went on to build Mistral. I wasn't too involved in that side of things, so I don't know what you're asking me, which is like, well, like how did they think about scaling laws and all of that. Llama 2, I was more closely involved in. I helped them a reasonable amount with like their infrastructure needs and stuff. Llama 2, I think, was more like, let's get to the evolution. At that point, we kind of understood what we were missing from the industry's understanding of LLMs, and we needed more data and we needed more to train the models for longer. And we made, I think, a few tweaks to the architecture, and we scaled up more. And like that was Llama 2. I think Llama 2, you can think of it as like after Guillaume left, the team kind of rebuilt their muscle around Llama 2. And Hugo, I think, who's the first author, is fantastic. And I think he did play a reasonable big role in Llama 1 as well, and he overlaps between Llama 1 and 2. So, and Llama 3, obviously, hopefully, will be awesome.
Just one question on Llama 2, and then we'll try and fish Llama 3 spoilers out of you. In the Llama 2 paper, the loss curves of the 34 and 70B parameter, they still seem kind of steep. So like they could go lower. How, from an infrastructure level, how do you allocate resources? Like, could they have just gone longer, or were you just like, hey, this is all the GPUs that we can burn, and let's just move on to Llama 3 and then make that one better?
Instead of answering specifically about like that Llama 2 situation or whatever, I'll tell you like how we think about things. Generally, we have, I mean, Mark released some numbers, right?
So let's cite those things again. Yeah. All I remember is like 600K GPUs.
That is by the end of this year, and 600K H100 equivalents.
Yeah.
Okay.
With 250K H100s, and including all of our other GPU or accelerator stuff, it would be 600 and something K aggregate capacity. That's a lot of GPUs. We'll talk about that separately, but the way we think about it is we have a train of models, right? Llama 1, 2, 3, 4, and we have a bunch of GPUs. I don't think we're short of GPUs. Like,
no, I wouldn't say so.
Yeah, so I think it's all a matter of time. I think time is the biggest bottleneck. It's like, when do you stop training the previous one, and when do you start training the next one? And how do you make those decisions? The data, do you have net new data, better clean data for the next one in a way that it's not worth like really focusing on the previous one? It's just a standard iterative product. You're like, when is the iPhone 1? You know, when do you start working on iPhone 2? Where's the iPhone? Like, so on, right? Yeah. So mostly the considerations are time and generation rather than GPUs, in my opinion.
So one of the things with the scaling law is like Chintala is like optimal to balance training and inference costs. I think at Facebook scale or Meta scale, you would rather pay a lot more maybe at training and then save on inference. How do you think about that from infrastructure perspective? I think in your tweet you say you can try and guess on like how we're using these GPUs. Can you just give people a bit of understanding? It's like, because I've already seen a lot of VCs say Llama 3 has been trained on 600,000 GPUs, and that's obviously not true, I'm sure. How do you allocate between the research, like FAIR, and the Llama training, the inference on Instagram suggestions that got me to scroll, like the AI-generated stickers on WhatsApp and all of that?
Yeah, we haven't talked about any of this publicly, but like as a broad stroke, it's like how we would allocate resources of any other kinds at any company. You run a company, you run like a VC portfolio. Like, how do you allocate your investments between different companies or whatever? You kind of make various trade-offs, and you kind of decide, should I invest in this project or this other project, or how much should I invest in this project? It's very much like a zero sum of trade-offs. And it also comes into play, like, how are your like clusters configured, like overall, like, what you can fit of what size and what cluster and so on. So broadly, there's no magic sauce here. Like, I mean, I think the details would add more spice, but also wouldn't add more understanding. It's just going to be like, oh, okay, I mean, this looks like they just think about this as I would normally do. Right.
So even the GPU rich run through the same struggles of having to decide where to allocate things.
Yeah, I mean, like at some point, I forgot who said it, but it's like you kind of fit your models to the amount of compute you have. If you don't have enough compute, you figure out how to make do with smaller models. But like, no one as of today, I think, would feel like they have enough compute. I don't think, like, I've heard any company within the AI space be like, oh yeah, like we feel like we have sufficient compute and we couldn't have done better. So like that conversation, I don't think I've heard from any of my friends at other companies.
Stella from Luther sometimes says that because she has a lot of donated compute.
Yeah.
And she's trying to put it to interesting uses, but for some reason she's decided to stop making large models.
I mean, that's a cool, high conviction opinion that might pay out, right? I mean, she's taking a path that most people don't care to take about in this climate, and she probably will have very differentiated ideas.
Yeah.
I mean, think about the correlation of ideas in AI right now. It's so bad, right? Like, so everyone's fighting for the same pie. In some weird sense, like that's partly why I don't really directly work on LLMs. I used to be I used to do image models and
GANs,
stuff.
yeah.
And I actually stopped doing GANs because GANs were getting so hot that I didn't have any calibration of whether like my work would be useful or not. Because, oh yeah, like someone else did the same thing you did. It's like, there's so much to do. I don't understand why I need to like fight for the same pie. So like, you know, I think like Stella's decision is very smart.
And how do you reconcile that with how we started the discussion about intrinsic versus extrinsic, kind of like a accomplishment of success? How should people think about that especially when they're doing a PhD or like early in their career? It seems like I think at New Reps, I walked through a lot of the posters and whatnot. There seems to be mode collapse in a way in the research. A lot of people working on the same things. Is it worth for like a PhD to not take a bet on something that is like maybe not as interesting, you know, just because of funding and, you know, visibility and whatnot? Or what suggestions would you give?
I think there's a baseline level of compatibility you need to have with the field. Basically, you need to figure out if you will get paid enough to eat, right? And whatever reasonable, normal lifestyle you want to have as a baseline. So you at least have to pick a problem within a neighborhood of like fundable. Like you wouldn't want to be doing something so obscure that people are like, I don't know, like you can work on it.
With a limit on fundability, I'm just like observing something like 3 months of compute, right? That's the top line. That's the like max that you can spend on any one project.
But like, I think that's very ill specified, like how much compute, right? So I think the notion of fundability is broader. It's more like, hey, are these family of models within the acceptable set of you're not crazy or something, right? Like even something like neural ODEs, which is a very like boundary pushing thing, or like state space models or whatever, like all of these things I think are still in fundable territory. When you're talking about, I'm gonna do one of the neuromorphic models and then apply like image classification to them or something, then it becomes like a bit questionable. Again, it depends on your motivation. Maybe if you're a neuroscientist, it actually is feasible. But if you're like a AI engineer, like the audience of these podcasts, then it's less, it's more questionable. So I think like the way I think about it is like you need to figure out how you can be in the baseline level of fundability just so that you can just live. And then after that, really focus on intrinsic motivation and depends on your strengths, like how you can play to your strengths and your interests at the same time. I try to look at a bunch of ideas that are interesting to me, but also try to play to my strengths. Mm-hmm. I'm not going to go work on theoretical ML. I'm interested in it, but when I want to work on something like that, I try to partner with someone who is actually a good like theoretical ML person and see if I actually have any value to provide. And if they think I do, then I come in. So I think you'd want to find that intersection of ideas you like and that also play to your strengths. And I'd go from there. Everything else, like actually finding extrinsic success and all of that, I think is, the way I think about it is like somewhat immaterial. Mm-hmm. When you're talking about building ecosystems and stuff, like slightly different considerations come into play, but that's a different conversation.
Yeah. I should we're going to pivot a little bit to just talk about open source AI. But one more thing I wanted to establish for Meta is like this 600K number, just kind of rounding out the discussion. That's for all Meta. So including your own inference needs, right? It's not just about training.
It's for all. It's gonna be the number in our data centers for all of Meta. Yeah.
Yeah. So like there's a decent amount of workload serving Facebook and Instagram and whatever. And then is there interest in like your own hardware?
We already talked about our own hardware. It's called MTIA. Yeah. Our own silicon. I think we've even showed like the standard photograph of you holding like the chip that doesn't work. I mean, like as in the chip that you basically just get like
as a test.
Test chip or whatever. So we are working on our silicon, and we'll probably talk more about it when the time is right. But
like, what gaps do you have that the market doesn't offer?
Okay, I mean, this is easy to answer. So basically, remember how I told you about the whole suite, like there's this memory hierarchy and like sweet spots and all of that. Fundamentally, like when you build a hardware, like you make it general enough that a wide set of customers and a wide set of workloads can use it effectively while trying to get the maximum level of performance they can. The more specialized you make the chip, the more hardware efficient it's going to be, the more power efficient it's going to be, the more easier it's going to be to find like the software, like the kernels to write to just map one or two workloads to that hardware and so on. So it's pretty well understood across the industry that if you have a sufficiently large volume enough workload, you can specialize it and get some efficiency gains like power gains and so on. So the way you can think about every large company building silicon, like I think a bunch of the other large companies are building their own silicon as well, is each large company has a sufficient enough set of verticalized workloads that have a pattern to them that, say, a more generic accelerator like an NVIDIA or an AMD GPU does not exploit. So there is some level of power efficiency that you're leaving on the table by not exploiting that. And you have sufficient scale and you have sufficient forecasted stability that those workloads will exist in the same form, that it's worth spending the time to build out a chip to exploit that sweet spot. Like obviously something like this is only useful if you hit a certain scale and that your like forecasted prediction of those kind of workloads being in the same kind of specializable exploitable way is true. So yeah, that's why we're building our own chips.
Amazing.
Awesome. Yeah, I know we've been talking a lot on a lot of different topics, and going back to open source, you had a very good tweet. You said that a single company's closed source effort rate limits against people's imaginations and needs. How do you think about that? How do you think about all the impact that some of the Meta AI work in open source has been doing, and maybe directions of the whole open source AI space?
Yeah. In general, I think it's worth talking about this in terms of open and not just open source, because like with the whole notion of model weights, no one even knows what source means for these things. But like, just for the discussion, when I say open source, you can assume it's just I'm talking about open.
Mm-hmm.
And then there's the whole notion of like licensing and all that, like, what
Commercial,
happens, commercial, non-commercial, commercial with clauses and all that. I think like at a fundamental level, the most benefited value of open source is that you make the distribution to be very wide. Like it's just available with no friction, and like people can do transformative things in a way that's very accessible. Like maybe like it's open source, but it has a commercial license, and I'm a student like in India. I don't care about the license. I just don't even understand the license. But like the fact that I can use it and do something with it is very transformative to me. Like I got this thing in a very accessible way. And then like, so it's very, very various degrees, right? Like, and then like if it's open source, but it's actually a commercial license, then a lot of companies are going to benefit from like gaining value that they didn't previously have, that they maybe had to pay a closed source company for it. So open source is just a very interesting tool that you can use in various ways. So there's, again, two kinds of open source. One is like some large company doing a lot of work and then open sourcing it, and that kind of effort is not really feasible by, say, like a band of volunteers doing it the same way. So there's both a capital and operational expenditure that the large company just decided to ignore and give it away to the world for some benefits of some kind. They're not as tangible as like direct revenue or something. So in that part, Meta has been doing incredibly good things. They fund a huge amount of the PyTorch development. They've open sourced Llama and those family of models, and several other fairly transformative projects. FICE is one, Segment Anything, Detectron 2, DensePose. I mean, it's
Seamless.
Seamless. Like, it's just like the list is so long that, we're not going to cover. So like, I think Meta comes into that category where like we spend a lot of CapEx and OpEx, and we have a high talent density of great AI people, and we open our stuff. And the thesis for that, I remember when Fair was started, the common thing was like, wait, why would Meta want to start a open AI lab? Like what exactly is the benefit, like from a commercial perspective? And for then, like the thesis was very simple. It was like, AI is currently rate limiting Meta's ability to do things, our ability to build various product integrations, moderation, various other factors. Like AI was the limiting factor. And we just wanted AI to advance more. And we didn't care if the IP of the AI was uniquely in our possession or not. For us, like, however the field advances, that accelerates like Meta's ability to build a better product. So we just built like an open AI lab, and we said, if this helps accelerate the progress of AI, that's strictly great for us. But like very easy rationale, right? Still the same to a large extent with like the Llama stuff, and it's a bit more. I think it's the same values, but like the argument, like, it's a bit more nuanced. And then there's the second kind of open source, which is, we built this project nights and weekends, and we're very smart people, and we open sourced it, and then we built a community around it. This is like the Linux kernel and various software projects like that. So I think about open source, like both of these things being beneficial and both of these things being different. They're different and beneficial in their own ways. The second one is really useful when there's an active arbitrage to be done. If if someone's not really looking at a particular space because it's not commercially viable or whatever, like a band of volunteers can just coordinate online and do something and then make that happen. And that's great. I want to cover a little bit about like open source LLMs maybe. So open source LLMs have been very interesting because I think we were trending towards an increase in open source in AI from 2010 all the way to like 2017 or something. Like where more and more pressure within the community was to open source their stuff so that their methods and stuff get adopted. And then the LLM revolution kind of took the opposite effect. OpenAI stopped open sourcing their stuff, and DeepMind kind of, didn't, like, all the other cloud and all these other like providers, they didn't open source their stuff. And it was not good in the sense that first, like science done in isolation probably will just form its own bubble where like people believe their own bullshit or whatever, right? So there's that problem. And then there was the other problem, which was the accessibility part. Like, okay, I again always go back to like, I'm a student in India with no money. What is my accessibility to any of these closed source models? At some scale, I have to pay money. That makes it a non-starter and stuff. And there is also the control thing. I strongly believe the best, if you want human-aligned stuff, you want all humans to give feedback, and you want all humans to have access to that technology in the first place. And I actually have seen, living in New York, whenever I come to Silicon Valley, I see a different cultural bubble. Like all the friends I hang out with talk about some random thing, like Dyson spheres or whatever, that's a thing. And most of the world doesn't know or care about any of this stuff. Like, it's like definitely like a bubble, and bubbles can form very easily. And when you make a lot of decisions because you're in a bubble, they're probably not globally optimal decisions. So I think like open source, the distribution of open source powers a certain kind of non-falsifiability that I think is very important. So I think on the open source models, like it's going great in the fact that LoRa, I think, came out of the necessity of open source models needing to be fine-tunable in some way. And I think GPUs. DPO also came out of the academic open source side of things. So why do any of the closed source labs did any of them already have LoRa or DPO internally? Maybe, but that does not advance humanity in any way. It advances some companies' probability of doing the winner takes all that I talked about earlier in the podcast. So I don't know, it just feels fundamentally good. When people try to, people are what are the ways in which it is not okay? And this might be a little controversial, but I find a lot of arguments based on whether closed source models are safer or open source models are safer, very much related to what kind of culture they grew up in, what kind of society they grew up in. If they grew up in a society that they trusted, then I think they take the closed source argument. And if they grew up in a society that they couldn't trust, where the norm was that you didn't trust your government, obviously, it's corrupt or whatever, then I think the open source argument is what they take. I think there's a deep connection to people's innate biases from their childhood and their trust in society and governmental aspects that push them towards one opinion or the other. And I'm definitely in the camp of open source is definitely going to actually have better outcomes for society. Closed source to me just means that centralization of power, which is really hard to trust. So I think it's going well in so many ways. There's not we're actively disaggregating the centralization of power to just like 2 or 3 providers. We are, I think, benefiting from like so many people using these models in so many ways that aren't allowed by like, say, like Silicon Valley left-wing tropes. Like some of these things are good or bad, but like they're not culturally accepted universally in the world. So those are things worth thinking about. And I think open source is not winning in certain ways. Like these are all the things in which, like, as I mentioned, it's actually being very good and beneficial and winning. I think one of the ways in which it's not winning, at some point I should write a long form post about this, is I think it has a classic coordination problem. I mean, open source in general always has a coordination problem. If there's a vertically integrated provider with more resources, they will just be better coordinated than open source. And so now open source has to figure out how to have coordinated benefits. And the reason you want coordinated benefits is because these models are getting better based on human feedback. And if you see with open source models, like if you go to like Reddit, local llama subreddit, like there's so many variations of models that are being produced, from say nose research to, I mean, like there's like so many like variations built by so many people. And one common theme is they're all using these fine-tuning or human preferences data sets that are very limited, and like someone published them somewhere, and like they're not sufficiently diverse. And you look at the other side, like say front ends like Uba or like Hugging Chat or Olama, they don't really have like feedback buttons. Like all the people using all these front ends, they probably want to give feedback, but there's no way for them to give feedback. So these models are being built, they're being arbitrarily measured, and then they are being deployed into all these open source front ends or like apps that are closed source, they're serving open source models. And these front ends they are not exposing the ability to give feedback. So we're just losing all of this feedback. Maybe open source models are being as used as GPT is at this point in like all kinds of ways, in a very fragmented way. Like in aggregate, all the open source models together are probably being used as much as GPT is, maybe close to that. But the amount of feedback that is driving back into the open source ecosystem is like negligible, maybe less than 1% of like the usage. So I think like some, like the blueprint here, I think, is you'd want someone to create a sinkhole for the feedback, some centralized sinkhole, like maybe Hugging Face or someone just funds like, okay, like I will make available a call to log a string along with like, a bit of information of positive or negative or something like that. And then you would want to send pull requests to all the like open source front ends like Uba and all, being like, hey, we're just integrating like a feedback UI, and then work with like the closed source people is also being like, look, it doesn't cost you anything, just like have a button. And then the sinkhole will have a bunch of this data coming in, and then I think a bunch of open source researchers should figure out how to filter the feedback into only the like high quality one. I'm sure like it'll be exploited by spam bots or whatever, right? Like this is like the perfect way to inject your advertising product into like the next.
Buy Coca-Cola now.
So there needs to be some level of that. That in the same way, I'm sure like all the closed providers are doing today, like OpenAI, Claude. Like with the feedback that comes in, I'm sure they are figuring out if that's legit or not. So that kind of data filtering needs to be done, and that loop has to be set up. And this requires that central sinkhole and that like data cleaning effort both to be like there. They're not there right now. They're not there right now, I think, for capital reasons, but also for coordination reasons. Okay, if that central sinkhole is there, who's going to go coordinate all of this integration across all of these like open source front ends? But I think if we do that, if that actually happens, I think that probably has a real chance of the open source models having a runaway effect against OpenAI with their current like daily active users, rumored. Probably doesn't have a chance against Google because, you know, Google has Android and Chrome and Gmail and Google Docs and everything, you know, so people just use that a lot. But like, I think like there's a clear chance we can take at truly winning open source.
Do you think this feedback is helpful to make open source models better or to get to like open source AGI? Because in a way, like OpenAI's goal is to get to AGI, right? So versus, I think in open source, we're more focused on personal better usage or like commercial
I think that's
usage.
a good question, but I think like largely I actually don't think people have a good understanding of AGI, and I don't mean definition level. I mean, people are like, okay, AGI means it's powering 40% of world economic output or something like that, right? But what does that mean? So do you think electricity is powering 40% of world economic output, or is it not? Like, generally the notion of like powering X% of economic output is not defined well at all for me to understand like how to know when we got to AGI or how to measure whether we're getting to AGI. Like, you know, you can look at it in terms of intelligence or task automation or whatever. And I think that's what we are doing right now. We're basically integrating like the current set of AI technologies into so many real world use cases where we find value, that if some new version of AI comes in, we can be like, this helps me more. In that sense, I think like the whole process of like how we think we got to AGI will be continuous and not discontinuous, like how I think the question is posed. So I think the open source thing will be very much in line with getting to AGI, because open source has that like natural selection effect. Like if a better open source model comes, really no one says, I don't want to use it because there are ecosystem effects. I'm logged into my ecosystem, or like, I don't know if I like the models, you know, whatever. It's just a very pure, direct thing. So if there's a better model that comes out, then it will be used. So I definitely think it has a good chance of achieving how I would think about as a continuous path to what we might define as AGI.
For the listeners, I will actually mention a couple other maybe related notes on just this very interesting concept of feedback sinkhole for open source to really catch up in terms of the overall Google versus OpenAI debate. Open Assistant was led by Yannick Kilcher, who recently ended his effort. I think the criticism there was like the kind of people that go to a specific website to give feedback is not representative of real world usage, and that's why the models trained on Open Assistant didn't really seem like they have caught on in the open source world. The two leading candidates in my mind are LMSys out of UC Berkeley, who have the LMSys Arena, which is being touted as one of the only reliable benchmarks anymore. I kind of call them non-parametric benchmarks because there's nothing to cheat on it except for ELO. And then the other one is Open Router, which is Alex Atala's thing. I don't know if you've talked to any of these people.
I obviously know all of the efforts that you talked about. I haven't talked to them directly about this yet. But the way I think about it is the way these models are going to be used is always going to be way more distributed than centralized. like, which is the power of the open source movement. Like the UI within which these models are going to be used is going to be decentralized. Like these models are going to be integrated into like hundreds and thousands of projects and products and all of that, right? And I think that is important to recognize. Like the AnyScale leaderboard is the best thing we have right now to understand whether a model is better or not versus another model. But it's also biased and only having a sliver of view into how people actually use these models. Like the people who actually end up coming to the AnyScale leaderboard and then using a model only use it for certain things, like GitHub Copilot style usage is not captured in say like LM6 things, and so many other styles like the character AI style things is not captured in LM6.
Which Open Router could do. They don't do it right now, but
yeah. So like I think like my point is like the way these models are going to be used is going to be always a large surface area, and I think we need to figure out how to provide the infrastructure to integrate with all these like ways in which it's being used. Even if you get like the top 100 front ends that the model, like the open source models are used through to subscribe to like the sinkhole, I think that's already like a substantial thing. I think like thinking one or two things will by themselves get a lot of data, I think is not going to happen.
Yep, fair enough.
Before we let you go, can we do just a quick beyond text segment? So you're an investor in Runway, which is a beta generation. You're an investor in 1X, which is a humanoid assistant. Osmo, which is focused on using AI for smell recognition and synthesis. You advise a bunch of robotics projects at NYU.
And he builds his own home robot.
Yeah, exactly. On a more, maybe open-ended thing, what are like the things that you're most excited about beyond like text generation and kind of the more mundane usage?
Yeah, I mean, in general, I have more things I'm generally excited about than I can possibly do. Investing is one way to try to clear those urges. I'm generally excited about robotics being a possibility, home robotics being like 5 to 7 years away into commercialization. I think like it's not like next year or 2 years from now, but like I think 5 to 7 years from now, I think like a lot more robotics companies might pop out. There's not a good consensus on whether hardware is the bottleneck or AI is the bottleneck in robotics right now. My view is actually hardware is still the bottleneck, and AI is also a little bit of bottleneck, but like I don't think there's any like obvious breakthroughs we need. I think it just work. So I'm generally excited about robotics. I spend a lot of time, or a lot of personal time. I spend like every Wednesday afternoon at NYU working with Laurel Pinto and team, and just getting towards my like home robot that just does my dishes and stuff.
What's the status of it? Like what does it do for you now?
As of today, we just deployed, a couple of months ago, we deployed our home robotics stuff into like several tens of New York City homes and like tried to make it do a bunch of tasks. And we're basically starting to build out a framework that gets to a certain level of robustness on fairly simple tasks, like, picking this cup and putting it somewhere else, or like taking a few pieces of cloth on the ground and put it somewhere else, or open your microwave, and like various like baseline tasks like that, with low sample complexity. So like the key thing, I think one of the things people don't spend enough time in robotics is like the user experience, which I think in the research I do at NYU, we spend a huge amount of time on. I think the key there is sample complexity has to be really low. A lot of the current robotics research, if you see, they're like, oh yeah, we collected like 50 demos and now it's able to do this task, or we collected like 300 demos, or like it's a sample. The number of samples you need for this thing to do the task is really high. So we're focusing a lot on you show it like 2 or 3 times, and that's sufficient for it to actually like do the task. But it comes with like less generalization, right? Like there's some initial conditions that have to be true for it to do the task. So we're making progress. That's very interesting in general, the space. I don't think people in the space have settled on the hardware, like how the hardware looks like for it to be truly useful in the home or whatever, or the UX, or the like AI ML stuff needed to make it sample efficient and all of that. But I think like lots of work is happening in the field.
Yeah, one of my friends, Carlo at Berkeley, he worked on a project called M3L, which is 2 CNNs, one for tactile feedback and one for image.
Yeah.
When you say hardware, is it running all these things on the edge, or is it just like the actual servos and
yeah. By hardware, I mean like the actual like servos, like the motors, servos, the even like the sensors. I think we have incredible vision that still like is so much better compared to in the field of view and in resolution compared to any of the cameras we can buy. We have our skin is like all available touch sensing, and we have like some of the most efficient, some of the most high capacity motors that can lift large loads, in like the dexterity of a hand and stuff. So in terms of hardware, I mean like in terms of those capabilities, like, we haven't figured out how to do a lot of this stuff. I mean, Tesla has been making incredible progress. 1X, I think, announced their Neo thing that looks incredible. Some of the other companies, Figure and like others, are doing great work. But we're really not anywhere close to like the hardware that we feel like we need. And there's obviously the other thing I want to call out is a lot of what people show works, but like has to be fixed all the time. I mean, like that's the other thing we are incredible at. Like we don't need any maintenance, or like the maintenance is part of us. If you buy a product, an electronics product of any kind, you buy a PS5, you don't say, oh yeah, my PS5 breaks like every 6 days and I have to like do some reasonable amount of work on it. But like that's robotics. Like if it's not industrial robotics where it's very controlled and specialized or whatever, like you're talking about reliability like in those ranges. So I think people don't talk about the reliability thing enough. Like when I mean like, we're going to enter the commercialization phase, I mean like we're going to start thinking about, okay, now we have this thing and we need to figure out how to get reliability high enough to deploy it into homes and like just sell it to people in like Best Buy or something. So that's the other factor that's we have to make a lot of progress on.
I just realized that Google has a play in this with like Palmy and stuff, and OpenAI obviously has a long history of doing this stuff. Is there anything at Meta? No robotic stuff in Meta.
I used to, we have a small robotics program at Meta out of FAIR. I actually used to do it at FAIR a little bit before I moved into infra and focused on my Meta time on a lot of like other infrastructural stuff. So yeah, Meta's robotics program is a lot smaller.
Seems like it would be a fit.
I think
personal computing.
You can think of it as like Meta has a ridiculously large device strategy, right? Like, this is how our Reality Labs stuff. Like, we're going at it from VR and AR and, we showcase a lot of that stuff. I think for Meta, like the robot is not as important as like the
screen real estate,
physical devices kind of stuff. Yeah, for sure.
Yeah. Okay, I want to touch on Osmo a bit because very unusual company to the stuff that we normally discuss. Not robotics, sense of smell.
Yeah.
The original pitch I heard from the founder, maybe you can correct me, is that you realize that you can smell cancer.
Yeah.
Is that intuitive? Is that what you get? Or
yeah, I mean, first, like, the very interesting reason I invested in Osmo is because Alex Rilsko, the founder of Osmo, also was like before PyTorch, there was Torch. And Alex Rilsko actually worked on Torch. He's actually like a frameworks guy. Like, he built this thing called Tangent from Google, like another like autodiff framework and stuff. Like, so I know him from that side of things. And then like I also like he's a neurobiologist by training. He just happens to also love like neural networks and like hacking on those frameworks. So incredibly smart guy, one of the smartest people I know. So when he was going in this direction, I thought it was incredible that like smell is something that we haven't even started to scrape in terms of digitization. When we think about audio or images or video, they're like so advanced that we have the concept of color spaces, we have the concept of like frequency spectrums, like, we figured out how ears process like frequencies in Mel spectrum or whatever, like logarithmically scaled images were like RGB, YUV, like we have so many different kinds of parameterizations. We have formalized these two senses ridiculously well. Touch and smell, nada. We're like where we were with images in say 1920 or maybe even the 1800s, right? That's where we're at. And Alex has this incredible vision of like having a smell sensor just eventually just be part of your daily life. Like as of today, you don't really think about like when you're watching an Instagram reel or something, like I also would love to know what it smelled like, where you're watching a reel of a food or something. You don't, because we really haven't as a society got that muscle to even understand what a smell sensor can do. I think the more near-term effects are obviously going to be around things that provide more obvious utility in the short term, like maybe smelling cancer or like repelling mosquitoes better, or stuff like that.
Yeah. More recently, he's been talking about like categorizing perfumes. Obviously,
exactly.
That's a market that you can pursue.
Yeah, like I mean, think about how you can customize a perfume to your own liking in the same way you can customize a shoe or something, right? So that's I think all the near-term stuff. I think if he's able to figure out a near-term value for it, they as a company can sustain themselves to then eventually like try to make progress on the long term, which is really an uncharted territory. Like think about it, 50 years from now, it would be pretty obvious to like kids of the generation to just like, I guess I was going to say scroll a reel on their phone, and maybe phones wouldn't be there. They're just like, on their glasses, they're watching something.
I think VR would be.
And then like they immediately get like a smell sense of that remote experience as well. Like we haven't really progressed enough in that dimension. And I think they have a chance to do it.
Awesome. I mean, we touched on a lot of things. Anything we're missing? Anything you want to direct people to, or?
Yeah, call to action.
Yeah.
Call for research, call for startups.
I don't really have a lot of calls to action because usually I think people should be intrinsically like figuring out.
That's a good
look inside yourself.
Yeah.
That's good. Awesome. Thank you so much for coming on.
Yeah,
this was
for
great.
sure.
Thanks, Soumith.